3 terms. This has 4 terms. 1, 2, 3, 4. So we cannot use the factor trinomial. And also, if you look at the product or special product or special factors, this will be a binomial, and this is a product, and this is a sum of 2 cubes. This is a difference of 2 cubes. So how can we subtract out this? So notice the greatest common factor of polynomial is 1 because x, the last term, does not contain an x, so therefore the greatest common factor is 1. Also, the polynomial has 4 terms. Therefore, we cannot use the technique from the previous example. So we will learn the factor of this polynomial by grouping. So if we group this polynomial into 2 groups, I can do it this way. For example, if the first one is x to the third plus 5x squared, we just group it with one group. One group with 2 terms. The second one will be negative 4x minus 20. So if we group this polynomial to group, the 2 terms of each polynomial as below. So we have the greatest, what are the greatest common factor of these 2 terms? That would be x squared. Very similar to the first one, we're looking for the factor completely. But this time a monomial, binomial. So you factor x squared out is equal to x plus 5. You factor the negative 1 4 out. You have x plus 5. And now, instead of the factor of great common factor as the monomial x or some number, this time the greatest common factor of the 2 group is x plus 5. This is the greatest common factor is a binomial. So we just factor out this x plus 5. So the remaining first term will be x squared minus 4. And x squared minus 4 go back to this special product. X squared minus 4 is something as x minus 2 squared. X squared minus 2 squared, and we're just using special product. X minus 2, x plus 2. So go back to the very basic special factors, the product. So that will be the final solution for the factor by grouping. So whenever you see 4 terms, then think about factor by grouping. Now on a high level, so they'll be a little bit different. You can sometimes you have 6 terms, or sometimes they have a special grouping. Not group 2, 2, but 3, 1. But that's the high level like trigonometry or pre-calculus. But not at this level. So now let's take a look at the first example as I explained. So now I have to write out for the board because I cannot write on the TV screen. X squared minus 8x minus 4x plus 16. So we group into 2 groups. What's the greatest common factor of these 2 terms? 2. Oh, before that. First one I go on. Let's do not the right way, but this is lengthy. So let's do this one, and I'll show you. Go back to the key for this one. You want always want to factor the greatest common factor first. So make the problem simple compared to this one. So if you don't see that, just complete that. What would the greatest common factor be 2 times?
2. 2x.
2x. So that would be x minus 4. What could be the greatest common factor of the second one? Negative 4. So x minus 4. Okay, what's the next step? What's the greatest common factor of these 2 groups? x minus 4 by the previous one.
Yes.
So you just factor x minus 4 out. And what the remaining for the first term?
2x minus.
That 2x, you just copy whatever's the term after we factor the x minus 4, and the second one will be negative 4. Now if you stop this, stop at that point, on your quiz, you lost some point. So how do we do this further?
You gotta factor the 2 out, right?
Okay, now this one have another common factor. So therefore, we need to factor the 2 out. X minus 2. And you have x minus 4. And now when you have a number and a binomial, I recommend write the number 2 out. The front will make it easier to understand. Then the other one will be a lot simple compared to this. Yes, you have a question?
I was just gonna ask, how come you want to, at the end of the problem, how come you want to factor the 2 out of the parentheses?
When you see the word completely, that means this we still factor further. Whenever you say the greater common factor, you need to factor out that.
Okay.
So this, if you stop here, this is called incomplete. Incomplete. So this will be the complete.
All right.
That answer the question?
Yeah.
Now, the other one is if you have, remember about the procedures, always factor out the greater common factor first. Even though this is x squared, x, and number, but what's the greater common factor of 2, 8, 4, and 16? 2. So that could be x squared minus 4x minus 2x plus 8. And now we do the group. Okay, this number 2 outside is the same. Then we want to group this. X will be the greatest common factor. Negative 2 will be the greatest common factor. And factor out x minus 4 out. So you have x minus 2. And you have a 2 outside. See, this will be the same. Except, sure. And also, make sure you do it completely. So now when you do this one, you don't worry about completely or incompletely. But this, you don't factor out a greater common factor, so you need to aware of incomplete factor. Any question? Okay. I think I already discussed this last meeting. Not all polynomials are factorable. Thus, if the polynomial is not factorable, then we can say the polynomial is not factorable or a prime. So I think this is the kind of remark we discussed last meeting. How about this one? Factor each polynomial completely. Anyone remember how to factor this is a trinomial? How do you factor that? Anyone? Remember how to factor this? X squared minus 5x. Plus 8. What's the first step? Now you need to remember about this procedure. Otherwise you may struggle or have trouble with it first quick. If you see the trinomial, what's the first step? Set up the product 2 binomial.
Always put the X.
such that the product of the two terms equal to x squared, x and x. Next step. Anyone? Suffice the product of the two number equal to 8. The sum equal to -5. Can we able to find the two numbers? So now, these are negative, so you want to focus on the negative number. -1, -8, -2, -4. I think that we have. Yeah, and this is -9, and this is -6. We cannot have, get the -5. So what's the conclusion?
Non-factor.
Not factorable or prime. So we set up a prime. That could be the conclusion. How about B? 3x squared minus 7x minus 12. So we do the same thing. What could be the first term of this two binomial?
3x.
3x and
X.
x. Because 3x times x is 3x squared. Then we just make a table like the previous one. Products, the sum equals -12, -7. So now this is both negative, so we need to do both negative and positive. So 1 -12, -1 12. Give me another pair such that the product two number equal to,
-6, 2.
okay, -2 and 6,
Oh,
2, -6,
-3, 4.
-3 and 4, or 3, -4. Okay, that's all possible. All of them. And now see this is 3. Be careful about this one, this is 3. So we need to have 3 times 1 of the number from this list, plus 1 times the remaining number, give us -7. Anyone see the number that will work for this one? No? How do you know? No.
-4.
Uh-huh.
Add, no. Non-factor. Right?
Not factorable? I don't know.
Not fact.
Not
No,
factorable, why?
because none of them equal to -7.
You try all of them, but just pick one pair because these two will it's the same result. So actually you need to test these 3. So let's do 3 times. Pick one, this pair. 3 times 3 plus 1 times -4. That's 9 minus 4, which is 5. So not equal to. And then you switch the numbers. So 3 times -3 plus 1 times 4